All right, this is 10.6 notes. This is writing in scientific notation. So our key idea here is we have two separate steps. So step one is we need to move the decimal point so it's located to the right of the leading non-zero digit. So for example, if my number is, I don't know, 6,874, okay, I find the first digit that's not a zero, which is this 6, and the decimal goes between the 6 and the 8. So the point of putting the decimal there is to make your number between 1 and 10. So 6,874, if I put my decimal between the 6 and the 8, now this number becomes 6.874, which makes it between 1 and 10. Step 2, I need to count the number of places I moved the decimal point. So my decimal point started here, okay, and I moved it 3 to the left, okay, and this indicates the number of power of 10 as shown below. So if I did this one, I would do 6.874, and this would be times 10 to the third, because I moved it 1, 2, 3 times. And here's a little something that you can remember it by. So number greater than or equal to 10, so 6,874 was greater than 10. Okay, so you're going to be moving the decimal point to the left, therefore your exponent is going to be positive. Okay, if your number is between 0 and 1, I have to put the decimal point between the 2 and the 4 to make that number between 1 and 10, and therefore I'm moving my decimal point to the right, which makes it a negative exponent. This will become easier once we have some examples. So, example 1, Google purchased YouTube, this is a true story, for $1,650,000,000. So I need to write this number in scientific notation. So the first thing I'm going to do is write the original and not hit the back button. I'm going to write the original value, so 1,650,000,000. I think that's right, 1, 2, 3, 4, 5, 6, 7. Okay. So, to place my decimal point, I need to place it between this 1 and this 6, because then I have 1.65, and I don't need to write all the rest of the zeros, okay? So I have 1.65, that's my number between 1 and 10, times 10 to the, I had to move the decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So this would be 1.65 times 10 to the 9. And that's it. Example 2, writing small numbers. So the 2004 Indonesian earthquake slowed the rotation of Earth, making the length of a day 0.000000268 seconds shorter. So write this number in scientific notation. So I have 0.000000268. Make sure that's 5 zeros. 1, 2, 3, 4, 5. Yes. Okay, so I need to place my decimal to the, don't worry about these zero numbers, these non-zero numbers between the 2 and the 6, okay? And you place that there because this now becomes the beginning of my scientific notation. So this would be 2.68 times 10 to the, and from here I have to move my decimal 1, 2, 3, 4, 5, 6 places to the right. And since I had to move to the right to make this number very, very small, it's 2.68 times 10 to the negative 6th power. And hit pause, try these on your own, and hit play when you are ready to go. All right, number 1, good grief. Number 1, my decimal is between my 5 and my 0. Now you really only have to write 5, so this would be 5 times 10 to the 1, 2, 3, 4th power. Number 2, decimal goes between the 2 and the 5, so this is 2.5. You do not need to write all these zeros. Times 10 to the 1, 2, 3, 4, 5, 6, 7th power. Number 3 goes between the 6 and the 8, so this would be 6.83 times 10 to the swoop, 10 to the 2nd. Number 4, my new decimal needs to go after this 5. Okay, so it's 5 times 10 to the 1, 2, negative 3rd power. This one, my decimal needs to go between these two 3's, so this would be 3.3 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. And lastly, number 6, my decimal point goes between my 5 and my 0. I'm looking for that first number that's not a 0 and putting the decimal after that. So I have 5.06 times 10 to the 1, 2, 3, 10 to the negative 4th power. Did I do those correctly? And I did, so let's move on. Example 3, we need to use scientific notation. So an album has sold 8,780,000 copies. How many more copies does it need to sell to receive the award for selling 1 million copies? Okay, so basically, and wait a second, what did I do? Oh man, this should actually be, alright, I totally messed this up. Instead of 1 billion, it would work if we did this, it's just going to be a giant number. So let's change this to what it's actually supposed to be, which is 10 million. Those numbers are a little bit more reasonable. Okay, so basically what I need to do is I need to take 10 million, and I need to subtract 8,780,000, okay, and I get 1,220,000. So that's how many more records it needs to sell. And then for good practice, let's write this number in scientific notation. So this decimal point needs to go between the 1 and the 2. So I have 1.22 times 10 to the 1, 2, 3, 4, 5, 6th power. What if the album has sold 955,000 copies? How many more copies does it need to sell to receive the award of selling? And this is not 1 billion. This is 10 million. I think. Yes. Okay, so same thing. Let's take 10 million and subtract 955,000. And when you do so, you get 9,045,000 copies. To write that number in scientific notation, the decimal goes between the 9 and the 0. And this is now 9.045 times 10 to the 1, 2, 3, 4, 5, 6th power. And last one. The table shows when the last 3 geologic eras began. So I need to order these eras from earliest to most recent. So what you need to do first is figure out what they are in standard form. So 5.42 times 10 to the 8th, I need to move my decimal 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And that becomes 5, 4, 2, 0, 0, 0, 0, 0, and 0. 6.55 times 10 to the 7th gives me 1, 2, 3, 4, 5, 6, 7. It is now 655, 0, 0, 0, 0, 0. And the Mesozoic is 2.51 times 10 to the 8th. So move it 1 time, 2, 3, 4, 5, 6, 7, 8. And that is that number. It does help if you put the commas in. I know it's a lot of zeros. Okay, so order the eras, not the numbers, order the eras from earliest to most recent. So the earliest will be the Paleozoic. I don't know if I'm saying that right. Paleozoic, maybe? And then the Mesozoic. And then the Cenozoic. And those are the eras from earliest to most recent. And that is it. See you tomorrow.